You might recall the definition of kinematics. It's all about where things move and not so much how or why they're moving. So we're just looking at what the motion itself looks like. And I want to talk about some kinematics equations for rotation. We had some from earlier in the semester, and now I'm going to bring in a few more that I think will be helpful. And there's 3 of them for the situation with constant angular acceleration, alpha. And all of this should look really familiar, and we'll talk about why at the end of this video. So the 3 equations we have: an angular position, theta, will be an initial angular position, theta naught, plus the initial angular velocity, omega naught, times t, plus 1/2 that constant angular acceleration times time squared. So that's the first one. The second one is that some angular velocity, omega, is your initial angular velocity, omega naught, plus that constant angular acceleration times time. And the third one, our final angular velocity squared, is our initial angular velocity squared plus 2 times the constant angular acceleration times a final angular position minus initial angular position, theta minus theta naught. If you've been refreshing on your dynamics, these should look sort of familiar, and they are directly comparable to some equations we had at the beginning of the class. So this first one, theta equals theta naught plus omega naught t plus 1/2 alpha t squared, looks a lot like our equation S is S naught plus V naught t plus 1/2 a t squared. Almost identical. The second one, this looks just like velocity is initial velocity plus acceleration times time. And this third one, the sad, lonely, forgotten equation, velocity squared, velocity naught squared, plus 2a s minus s naught. So I'm not actually going to derive these angular ones because the derivation looks exactly the same as the derivation was for these linear kinematic equations that we did earlier in the semester. So go back, look through your notes, you can see how we did these derivations, and the derivations are exactly the same for angular situations. And these are going to be really helpful to have in our pocket as we think about how things move in rotation and combining translation and rotation.